Today we're going to be talking about the production of metal sheets and coin blanks that are created by the US Mint when they're trying to design and create circulating and proof coinage. Now, in order to do this, I want to give you a brief introduction, a brief overview of the US Mint coin production. Now, the US Mint, or the United States Mint, is an agency within the Department of the Treasury, and they hold crucial responsibility of producing the nation's coinage to facilitate things like trade and commerce. Now, along with the Bureau of Engraving or Printing, or the BEP, it stands as one of the two governmental entities that are tasked with the physical creation of U.S. currency. Now, the Mint's output encompasses circulating coins used in everyday transaction, as well as bullion and numismatic coins that cater to investors and collectors, respectively. Now, the significant operation is carried out across 4 active coin producing facilities strategically located throughout the United States. Those are Philadelphia, Denver, San Francisco, and West Point. Each of these facilities play a distinct role in the overall ecosystem. Now, the Philadelphia Mint, which is the oldest and the largest of all the mints, engages in a broad spectrum activities, including things like the production of circulating coins, the creation of coin dice, and the minting of commemorative coins and national medals. Denver focuses primarily on the high volume production of circulating coins, and they also do some die manufacturing for this process. The San Francisco Mint, however, has a primary shift towards producing either proof coins or those specialty strike coins. Now, they've been minted specially for collectors, and these are known for their intricate designs and higher quality. Finally is the West Point Mint, and the West Point Mint is primarily bullion coins. Now, they do, on occasion, do special runs, but their primary focus is coins made from precious metals like gold, silver, platinum, palladium, along with commemorative and proof coinage. Now, the methods employed in each of the productions have undergone remarkable transformations since the United States Mint's inception in 1792. Initially, it relied on slow, labor-intense machinery, powered by horses, manual labor, and the process evolved throughout the adoption of steam power and ultimately to a very high-efficient, computer-controlled machine that are in use today. Now, the evolution reflects the continuous process of enhanced efficiency and increased production capacity to meet the demands of our growing economy. So now let's talk a little bit about the metal composition and some of the specifications of U.S. circulating coins. We know there's an array of U.S. circulating coins that are in production. They include the cent, we call it affectionately the penny, the nickel, the dime, the quarter, the half dollar, and the dollar. Now, each of these denominations possess unique specifications regarding its metallurgic composition, its weight, its diameter, its thickness. For instance, the penny, as seen here, or the cent, is composed of copper-plated zinc core, with copper making up 2.5% of its weight and the zinc comprising the balance. It weighs 2.5 grams and has the diameter of 19.05 millimeters with a thickness of 1.52 millimeters. The edge of the penny is plain. Now, when I say it's plain, it's not lettered or reeded, as you'll see in some of the other coins. The nickel is made of a copper-nickel alloy, consisting of 25% nickel and 75% copper. It weighs 5 grams and has a diameter of 21.21 millimeters with a thickness of 1.95 millimeters. Similar to the penny, this one also features a plain edge. The dime also utilizes copper-nickel alloy. However, the proportions are a little bit different. 8.33% nickel with the remaining being copper. It's lighter than the nickel, weighing only 2.268 grams, and has a small diameter of 17.91 millimeters with a thickness of 1.35 millimeters. Now, this is a little bit different, as this is the first coin of the three that actually has a reeded edge. Trivia piece for you. How many reeds are on that edge? Well, there's 118. The quarter shares the same cupronickel design as the dime, 8.33 nickel, balanced copper, and weighs 5.67 grams, has a diameter of 24.62 millimeters and a thickness of 1.75 millimeters. Now, this also has a reeded edge, but this one has a reeded edge of 119 reeds. The half dollar continues with the 8.33 nickel copper composition. It is the heaviest of the cupronickel coins, weighing in at 11.34 grams. It also has the largest diameter at 30.61 millimeters, with a thickness of 2.15 millimeters. Now, it also contains a reeded edge, and the half has 150 reeds on this particular coin. The dollar, on the other hand, is a unique composition. This one, as they affectionately call the gold dollar, isn't gold at all. It's what they call a manganese brass. It consists of 88.5% copper, 6% zinc, 3.5% magnesium, and 2% nickel. It weighs 8.1 grams and has a diameter of 26.49 millimeters. Now, the thickness on this one is exactly 2 millimeters. Unlike the other circulating coins, however, the dollar features edge lettering instead of the plain or reeded edge. Now, this changed because the dollar used to have the date on the face or on the obverse of the coin, but now you will see that it's located on that edge. Now, it's important to note that the penny, dime, quarter, half dollar, and dollar are all classified as clad coins. This hasn't always been the case. So what does it mean to be clad? This means that they are constructed with an inner core of copper and it's surrounded by an outer layer made of a different metal alloy. The nickel stands out as the only one of the circulating coins that does not employ the clad construction. Again, this hasn't always been the case. The nickel is a solid alloy of cupronickel throughout. The layered approach in coin composition, along with the shift towards utilizing less expensive base metals like copper, nickel, and zinc, help to reflect the adaptation that's happened to increasing costs associated with the more valuable metals. Those of you who are a stacker will know that the price in silver and gold over the years has dramatically increased, which historically are what US coins were made of. Now, the transition to clad composition-based metals for circulation coinage was primarily motivated by economic considerations, primarily the escalating price of those precious metals. Now, we know this. We've talked about the Coin Acts. We've talked about some of the recalls, the confiscations, as many people would call, that happened with 1933, and then silver taking over as the monetary base, and then by the 1960s, us going to non-silver-based coinage. This led to the adaptation of effective solutions, the copper core sandwiched between various layers of cupronickel or zinc. Now, the meticulous control of this has been precisely composed by each denomination, and it serves a couple different purposes. The meticulous control over these precise metallic composition for each denomination serves a very specific purpose. Well, actually, it's two. First, the uniformity across coins in a given denomination. This is very important because it allows for a certain function in commerce. Secondly, the specific alloy used and its proportion allows it to be utilized as a security feature, such as a unique electromagnetic signature that can be utilized in vending machines and coin accepting devices. The U.S. Mint's exploration of alternative metals with distinct electromagnetic properties underscores the importance and aspects of coin design and production. Many people don't think about the metallurgical composition when they're looking at coins, but this is very important when you're looking at the authenticity of modern coinage. Now, the process commences with the introduction of a 1,500-foot-long metal coil. Now, this takes specialized machinery where these coils are manufactured to meet the specification dedicated to each of the individual denominations. This step includes feeding this through a straightening machine, which then gets filtered into something we know as blank production. Now, following the straightening phase, the coins are fed through the blanking press, and these operate at high speed with amazing efficiency. And these are capable of punching out thousands of coin blinks every minute. The blanks are cut with a high degree of accuracy, often using laser-based technology to help ensure uniformity in their size. While these blanks have the same thickness as the finished coins, they have a larger diameter because they're going to go into another process called upsetting. See, after the blanks are cut, they are then transported to an annealing furnace. Annealing is crucial when you're talking about heat treating processes because it softens the metal, making it more malleable and more suitable for the striking of the coin. But as they elevate this to the temperatures, heating it up to as high as 1600 degrees Fahrenheit, it is done in an oxygen-free environment. Now, the absence of oxygen in this phase helps to prevent tarnishing. When the desired temperature is reached, the blanks are rapidly cooled and dropped into a quench tank filled with a special solution. During much of the blanking process, the portion of the metal that is not utilized, which is webbing, is recycled because, again, it's important that they demonstrate a commitment to resource efficiency. Bottom line is they need to be profitable. Following the annealing process, the blanks undergo a washing stage to restore their original metallic color. Now, again, you're going to have changes after being annealed. They achieve this by using a solution containing an anti-tarnishing agent. Now, after being thoroughly washed, the blanks are then dried to prepare them for the next step in the process. And the final step in the process is called upsetting. Now, once this blanking process is done, they are turned into a planchet. Now, they do this by feeding this into a groove that is slightly narrower than the diameter of the larger coin. What this does is this pushes the metal upwards, creating the characteristic rim. Now, once the blank is raised into the rim, it technically is now referred to as the planchet. Now, the rim serves an important function of production because it helps protect the coin's design from wear during circulation, and it also helps make the coins easier to stack. In-house production of the blanks represents a highly automated and efficient manufacturing process. The speed of the blanking process, the capability to generate tens of thousands of blanks per minute, coupled with the continuous feeding of these large metal coils, indicates a high throughput production. The integration of the various stages, including straightening, blanking, annealing, washing, drying, upsetting, further advances the level of automation that is employed by the U.S. Mint, focusing on the most important aspect, which is the strike. It also sources certain blanks and denominations, including pennies, numismatic coins intended for collectors, and all bullion coins for precious metals. When they mint these blanks from external suppliers, they typically arrived ready for striking, which means they're ready and they've already undergone the blanking, the upsetting, the washing, and technically are classified as planchets instead of unfinished blanks. Upon receiving the shipments of these, officials of the U.S. Mint conduct inspections to ensure that they meet the stringent quality standards and specifications required for that particular coin. Security is also another issue that is very important to ensure that they don't have somebody inadvertently or on purpose making coins that are not meeting the specifications. Doing so is an illegal act. And as you've seen with the Mint employee in the year 2014, convictions have been made because large number of manufactured damaged coins are being sold on the resale market. These have high costs and give a bad representation of the Mint's quality control standards. The Mint continues to utilize advanced analytical methods for quality control. We've talked about X-rays, not only for the machines, but for the employees as well. Looking at non-destructive means by assessing the precise metallic compound. We also see this in the stacking community when we look at gold and silver bullion. Sometimes, because of the thickness, some of your XRF machines may not work like they should, and you might need to x-ray the precious metal to ensure it is the right composition, to ensure somebody hasn't done something nefarious and put steel rods or some other metal substance in the center of that large bar. The Mint also has been actively involved in researching and testing alternate metal compositions. Now, we've seen this in the past, but continues to be testing protocols to evaluate the performance and suitability of the alternate materials. These tests combine and encompass assessments of wear, resistance to things like corrosion, the hardness, and the analysis of the electromagnetic signature of the metals. Again, important in vending. Furthermore, the leverage the Mint utilizes in the advancement of measurement science to optimize things like coin production processes. The production of metal sheets and coin blanks by the US Mint is a multifaceted process. It combines in-house manufacturing for the majority of its circulating denominations with strategic sourcing for other specific needs. These in-house processes, characterized by its high degree of automation and efficiency, allow for the rapid production of a large volume of blanks while incorporating recycling of scrap metal. However, when we look at pennies and other numismatic coins, remember that the US Mint relies on external suppliers, notably Artisan. This is the sole provider of the copper-plated zinc planchets for pennies. Now, we have different providers and different purveyors for the precious metal. Now, we do this to ensure that they meet the stringent quality standards set by the US Mint for each denomination, proof, or bullion coin. Now, the decision to manufacture some blanks all reflects the strategic balance of in-house capability, cost consideration, and the need for specialized equipment and experience. It underpins the entire production process as a comprehensive framework of quality assurance measures and continuous process improvement. These measures are implemented at every stage in the process, from the very inspection and testing of the raw materials, including hardness, composition, in-process checks, blank production, examination of the finished coins after striking, and even the packaging process. The Mint employs both automated systems and well-trained staff to ensure and remove any defective coin. But things happen, and on occasion, they come out. This is why we collect and look for errors and varieties. Furthermore, the US Mint has a long-standing commitment to the utilization of advanced testing methodologies, including both historical and modern coinage. Now, this ensures that all US coins meet that specific required specification for composition, weight, and physical integrity, not only to maintain security, but to help ensure reliability, trustworthy coinage, and to prevent counterfeiting. I hope you've enjoyed this talk about the US Mint, about its processes, and looking at some of the metal composition and the coin blanking process by the US Mint. My name is Frostbyte. If you've enjoyed this, please do me a favor. Subscribe to the channel, hit that notification bell, and stay tuned for more great videos like this. Have a great day, and I will see you soon.